so we're going to be doing section 1.6. This is solving linear inequalities. All right, so here's the steps to do this. So you're going to simplify the expression. So you're going to simplify the expression as much as you can. You're going to use addition and subtraction to move constant terms and the variables to one side. So you're going to try to get all the variables to one side, everything else to the other side. You're going to use multiplication or division to eliminate the variable's coefficient. So here we'll get rid of the coefficient. If each side of the inequality is multiplied or divided by negative numbers, you switch the sign. So if I add or minus numbers, it doesn't change anything. But if I multiply or divide, I switch the inequality sign. We just check. We just check a couple solutions to make sure it works, and then we state the solution set and summarize in a complete sentence. Yeah, we don't need to do that completely. So let me explain. So here, how to solve inequalities. And so the first thing you want to do is get the variable on one side and then the constant terms on the other. So hold on, let me pull up something real quick just for my own sanity. All right, so here we're going to minus 5 from both sides. So I'm going to minus 5 here and minus 5 here. So I'll give you minus 3x. It's greater than 6. And hold on, before I even get into all this, let me do some things here. So there's two ways of thinking about this. So this is the greater than symbol. We call this greater than. And then this is the less than symbol. And then here, if we have lines under, then it's greater than or equal to, and this is less than or equal to. So the line means and equal to. So there's two ways of thinking about this. I don't want kind of curious which ways you learn. So the first one is if you have, so like 9 is greater than 7 and negative 8 is less than 2 because it's more negative, right? Does that make sense? So there's two ways of thinking about this. One, the arrow points to the smaller number, so it points to the smaller number. To the smaller number. Or the other one is the alligator eats the bigger number. I'm kind of curious, which one did you learn? The alligator or the arrow? The gator. Pretty much all the alligator eats the bigger one. The shark, even better. I love that. I was teaching this class for in PCC, so Portland Community College, and one of my students is like, I should get a sock puppet for the first day. So one of my students made me a sock puppet. So the next time I taught the class, I literally put on a sock puppet. That's because I'm not a sane human, but it was fun. So yeah, so either way you can think about it. So it's the greater than and less than. So here we want this to be greater than. All right, so now that we've done this, shout out for my hometown of Portland. Yeah, isn't it a mess right now? We won't get into it. Legit won't get into it. I do miss it though. It's so much cooler than this heat. All right, so now that we've done this.
Hey.
So now that we've done this, we've simplified. This is already simple. We isolated, so we have the variable on one side, the constant terms on the other. Next thing is to eliminate the coefficient. Here we're going to divide out by -3. And since I'm dividing by a negative number, I need to switch my inequality. So it'll be x greater than -2. Okay. So once I have it in this form, I can write out the inequality. Inequality here is x greater than -2. Here we're going to use, I'm going to mark somewhere on my number line to be 0. And then I'm going to go 1, 2. Oh, no, it's x less than x. Oops. This is the less than symbol. This is x less than -2. Sorry. So this is x less than -2. So I'm going to mark out this, and then it's going to be less than goes like this, and then we just fill out the area, all the values less than that. Interval notation, that means I'm allowed everything from minus infinity to 2, and we're going to use the parenthesis here to indicate it's not equal to, but only up to that. Set builder notation, if you remember, is x such that x is less than minus 2. And then the last thing we want to do real quick is just test a couple points. So x is less than minus 2, so let's test negative 5. So if I plug negative 5 into the original, right, so I'll have 3 times minus 5 plus 5. Is that greater than 11? Well, let's test it out. This becomes 15, and negative negative, so this is positive 15 plus 5 greater than 11. So we have 20 greater than 11, so we're good, right? So this works out. So it's good just to test a single point, at least, in your set. And so this is how you solve inequalities. We'll do a couple more. All right. So I will do example 2 with you, and then we're going to have you guys try example 3. So here, solve the linear inequality below. So we're just going to, and we'll fill it all out. So here, I need to isolate my variable. So I'm going to move 3t over on this side. That way I can keep my t's positive. Then at the same time, I'm going to move over 7 to this side. So here I'm moving t's this way, and I'm moving my constants that way. So 8t minus 3t would be 5t. 7 plus a 7 is 0. This is less than or equal to this time. Here we have 3t minus 3t is 0, and then negative 2 plus 7 would give us positive 5. Oops. There it goes, positive 5. Now, we just want to isolate the variable. We're going to get rid of divide 5 from both sides. Since this is positive, I do not need to switch the sign. So I have t is less than or equal to 1. So here I have t less than or equal to 1. Here I'm going to put in my 0, just to put a 0 in. I'm going to use the dot this time just to show you both. And notice here that this right here points in the direction of your line, the direction. I can spell direction. Direction of your line. And so here, it's everything less than this, and notice that's going to point to everything less than this. If there's everything greater than this, it'd be the other way, and then you just fill it out like that. Okay, so I have that. The interval notation, so is negative infinity, and this time we actually do make it to 1, so I put a bracket. It means I can get there. Okay, means I can get to this number. This number means included. And then set builder notation is the following. And once again, if you forgot, these brackets means the set of t such that, this line right here means such that t is less than 1. So this is all t less than 1. And we're going to test 1 point. 0 works. So we're going to test 0. So 0 is a good point to test. If I plug 0 into this, I'll have negative 7 less than or equal to negative 2. And that is correct. Because even though 7 is a larger number, it's negative, and so it's more to, this less than means really more to the left on the number line. And so here, 1, 2, 3, 4, 5, 6, 7. So this would be minus 7, and this is minus 2 on our little thing. And so since negative 7 is more to the left on my number line, it's less than that, okay? All right, so give number 3 a try without me. And then I'll do 4 with you. And then we'll briefly go over the homework. And then I might do 1 problem with you before we leave today. But since we went over last time, I'm okay going under this time. All right, so try 3 on your own. You will have to simplify. You will have to simplify this. So simplify this. And then once you have your answer, just tell me the inequality and we'll do the rest together, okay? And I'll wait till about 3 or 4, 4 or 5, I guess, have answers and post them in chat. And for those, I really do want you to try. That way you can understand and ask questions. Okay, so we have one answer out. I won't weigh in if it's correct or not. Okay, we have more answers out. Okay, so I think I have enough answers to go forward. All right, so I have what looks like to be basically the same answer. Okay, so let's go through it. So the first thing we want to do here is distribute the 2. So we're going to have negative 5x minus 9 less than 2x minus 6. All right, so you have 2 options at this point. It looks like most people did option where you just moved all the x's to the side. So you minus 2x here, you minus 2x here. You added a 9, added a 9. So here I have minus 7x less than positive 3. And then here we're dividing out by a negative 7. And when we divide by a negative 7, we swap the signs. So x to x is less than, or greater than, sorry. X is greater than a negative 3/7. Now the other option is you can move stuff the other way. And let me show that real quick, just because I want to show something else at the same time. So this would be minus 5x minus 9 less than or equal to 2x minus 6. So here I could have moved the 5 over and then added the 6. And so here I'd get minus 3 7x. And then I get minus 3/7. These are the same answer, because notice x being greater than negative 3/7 is the same thing as negative 3/7 being less than x. So this is the exact same, okay? So I have a tendency to do it this way because I like to keep my x positive, though I do need to go from here, take this and just flip it all anyways here, because I'll write it this way, it's minus 3/7. So these are the same. These are the same answer. Okay. Here we're going to put in a 0. Here we're going to give us a little bit more room. We're going to get 1, 2, 3, 4. Oh, give me a 1 and then 1, 2, 3, 4. Make that minus 1. So negative 3/7. Oh, okay. Whoa. Why didn't you switch to second? Oh, yeah. Yeah, so here in the second example, when I divide out the 7, my 7 is positive. Okay, good. I'm glad you asked the question. So whenever we divide by negative, we swap the signs. So whenever you divide by negative, you swap the signs, or multiply by negative, you swap the signs. If you add or subtract, you never swap such signs. And so here, one, we do swap the signs because I divide by negative. Here, I didn't because I purposely moved the x this way, not to. But then you still have to flip this to look like this, so it ends up being the same. All right, so let's go back to the other notation. So negative 3/7, and so that's a little bit less than let's see, 3/7 would be about a little bit less than half of it, so somewhere around here, I guess. And then it goes out this way, okay? So remember, this arrow points in which way you go. Interval notation, we're not including -3/7, so that's why we have the parentheses all the way to positive infinity. We never include positive infinity or negative infinity, so that's always a parenthesis. And then we'll do the set builder notation here. X minus 3/7. Okay. All right, let me show you how to do this one. We call this a compound inequality. And so in order to solve this one, we're going to do the same thing, but when I do something, I have to do it to each of the sections. And so I want to get 3x by itself, so I'm going to add 2 here. But if I add 2 here, I need to add 2 here, and I need to add 2 here. So when you see one of these, we have to do a 2, a 2, and a 2. So this field becomes 6 less than or equal to 3x, which is less than or equal to, oh, no, just less than, sorry. 15. All right, so now we have that. Now we can just divide out the 3. This 3 is positive, so I don't need to swap signs. And so I'll have 2 less than or equal to x less than or equal to, oh, no, keep on make that equal to, just less than 5. And so that's my inequality here, 2 less than x less than 5. And then we'll plug in a 0 here. We'll go 1, 2. That's a solid dot. Or we could do a bracket. 3, 4, 5, and that's an open one. Let me just fill it in like that. Or another way of doing this, we could have had a bracket, 2 parentheses. Both of those work. The interval here is from 2 to 5, not including 5. And the set builder notation is just x such that 2, comma, x, 5. Okay. Now we're going to test one point real quick. So the point we'll test is 3. So let's plug in 3 into the original. So we have 4 less than or equal to 3 times 3 minus 2, which is less than 13. So here I'll have 4. This is 9 minus 2, so that'd be 7, which is less than 13. So that works out. Okay. Yeah, let me do one more with you. Let me do one more with you, or have you guys try one more, and then I'll do it with you. Let me just open a new page, new file. I want you to do at least one more. Yeah, just a blank sheet. I'll make one up. Let's have minus 6 is less than, or equal, it's just less than negative 2x plus 4, which is less than or equal to 10. Yeah, so go ahead and try this one and then give me the answer to it. All right. If I get one more, we'll go through it. Okay, we got one more. Perfect. All right, let's go through it. All right, so here we go. So let's see. So first thing we want to do is minus, oops. We want to isolate this one, so it'll be minus 4 from both sides. Or actually all 3 sides in this case. And so here I'll have minus 10. Make sure I'm doing this right. Minus 10 minus 2x. 10 minus the 4 will give me 6. And then I'm going to divide out by minus 2 everywhere. And since I divided by minus 2 everywhere, I must flip all my signs. So here we'll have 5 greater than 2x, or no, I got rid of the 2. X greater than or equal to minus 3. And then when we write it And standardly, you write it the other way. So it'll be minus 3 less than or equal to x less than 5.